Thank you. Hi, so I'm Aditya from Northeastern University in Boston. My presentation is on the potential applications of video games to crowdsource raw sensor data annotation. So our research group is primarily interested in designing activity recognition algorithms. And one of the big challenges we face in this process is gathering high-quality accelerometer data annotations. These annotations require human input, and so we are interested in using video games to crowdsource this data annotation task. So in this paper, we are presenting two human computation games to crowdsource raw data annotation. We demonstrate that casual game players may be able to label movement patterns in the raw sensor data. We show that puzzle-based games may be more suitable for this kind of labeling task than a more rhythm or action-based games. And finally, we discuss some opportunities for algorithms, players, and experts to come together and collaborate on labeling large-scale accelerometer data sets for health surveillance studies. Accelerometer-based activity recognition is basically detecting activities using machine learning algorithms. Most of the time, they use body-worn miniature accelerometers like the one on my wrist, and they process raw accelerometer data from these devices to infer activities. So these devices can be worn on wrist, ankle, hip, or thigh, or any other part of the body, and they measure acceleration, which is the rate of change of velocity, along x, y, and z axis. And that's why different movements generate different visual patterns of acceleration along these three axes. For example, if a user is running, it generates a more rhythmic pattern along these three axes. If a user is sitting and typing, it generates a more noisy pattern of acceleration. Most of the research today follows a very similar protocol where domain experts or researchers gather raw accelerometer data from a set of participants. These participants wear these one or more sensors on their body and perform several activities. Researchers then label this data either retrospectively or in real time when the participants are doing these activities. And finally, they use the labeled data set to train their activity recognition algorithms using a variety of machine learning approaches. But we know that most of these approaches require large data sets, and they depend on very high quality of annotations. But labeling accelerometer data, especially the raw data, is not trivial. Many small research groups don't have sufficient human resources to label these data sets. And honestly, labeling large accelerometer data sets is very time-consuming and a very boring task. So we are interested in a scenario where in the perfect world, domain experts can take their large data sets, send it to casual game players who just by playing the game will label the data, and then this labeled data set can be used to train activity recognition algorithms. So in this paper, we designed two human computation games to crowdsource this accelerometer data annotation task. The first game we designed is called Mobots, which is a rhythm-based labeling game inspired by Guitar Hero, which most of us are familiar with. So here players label moving accelerometer data fragments one at a time. So these data fragments contain one or more different activities that the participants have done, and players have to identify and label them. The second game we designed is called Signal Liner, which is a puzzle-based game to label accelerometer data. The game is inspired by a genome sequencing game called Philo, where players label or match accelerometer data patterns by cutting and aligning data fragments. So unlike Mobots, where they have to identify an activity in the data and then label it, Signal Liner is just a pattern matching task. So they have to check if a given fragment visually matches with the template that they have been provided. We then, the data that we used in the pilot game prototypes was collected from some participants who wore accelerometer on their non-dominant wrist. And our research group then labeled this data set into several categories, including walking and running activities, sedentary activities, and sleep patterns. We then divided this data set, this labeled data set, into two parts. The first part that was used in the game is called validation data, which is used as the ground truth in the games to provide in-game feedback to the players and to provide training during the tutorial levels when they're teaching them how to label these activities. The second part of this labeled data set is called unknown data, which is used to get the annotations on. So this is the data that researchers should be actually using to get annotations on their own data sets. But games do not know the ground truth on this data set. But because our research team already has all the labels, we use this to evaluate players' performance after they have played the game. So we evaluated our game prototypes in a pilot study with 100 players for each game using Amazon Mechanical Turk. So the games were play tested on first the interplayer agreement. That means how much did the players agree on a label for a given sample of data. Labeling accuracy, how correct were players' labels compared to the ground truth data we already had. And finally, for exploratory purposes, we also compared players' labels with a state-of-the-art activity recognition algorithm that we had developed in our lab. So we can take a look at the results in details for each of the games. So for Mobots, we have, let's say, 4-minute sample of raw accelerometer data. And then we have the labels that our research group had assigned to this data set. So you can see the first part of the data is walking activities. Second part is setting activities. And then we have labels from casual game players who played Mobots. These are the players who have no background in machine learning or exercise science. So Mobots players had a labeling accuracy of 89%. But what's interesting is that they did a good job of identifying all the walking and running activities in the data fragments. We think one of the big reasons for this could be that walking and running activities have a very distinct rhythmic patterns. So this pattern is easily distinguishable even in a game like Mobots when the signals are moving at a very high speed. If you look at the results from the second game we designed, which is Signal Liner, let's say we have the 20-minute sample of the raw data that players played on, followed by the ground truth labels from our research team, and once again from a set of casual game players who played this particular data set. Signal Liner players actually had much higher labeling accuracy of 99% and a higher interplayer agreement. Signal Liner players actually agreed more often than the Mobots players when labeling data. We think there are two reasons for this. First, Signal Liner is just a pattern matching task. They don't really have to identify an activity and learn how to spot it. They just had to check if it matches visually with the template that they have been provided. So it's a much easier task to do. Second, in Signal Liner, players could spend their own time to explore the signal, find out the right transition points, and cut out the fragments evenly whenever they want to. So that's why we think perhaps a puzzle-based game approach may be more appropriate for this kind of a complex and a rather boring data annotation task. And we also compared players' labels with an activity recognition algorithm. In the interest of time, I'm not going into the details of what the algorithm does. But we have provided that detail in the paper along with many other interesting results. So let's say we have 2-minute sample of raw data from Mobots players. These are the labels from the players with their interplayer agreement for the same data. And these are the labels from the algorithm for a 30-second time window with the algorithm's confidence. So we see some really interesting trends here. First, we can notice that there are instances where the algorithm is clearly wrong. It thinks the person is sleeping, but actually it's not a sleep data. But players got it correct. These are the instances where players with no background in machine learning can provide feedback to an algorithm just by playing the game. But there are also instances where the algorithm is correct, but players are wrong. And here algorithm can be used to provide feedback to the players when they're labeling unknown data. Between these two edge cases, there are opportunities for algorithms, players, and domain experts to collaborate and label large-scale accelerometer data sets. So for instance, the way we envision this is that domain experts can take their raw data, pass it through the algorithms that they have, and get the first set of labels. These labels can then be sent to casual game players who, by playing the game, would refine the annotations further. The refined annotations can either be used to retrain the algorithms, or they can be sent back to the experts so that experts can iterate over. This way, we would not need a lot of players to actually play the game. At the same time, we could save the human computation time or the amount of time players spend labeling this data. So in summary, we presented two human computation games to label raw accelerometer data. We showed that casual game players may be able to label movement patterns in raw data, but in this study, we have barely scratched the surface and clearly more research is needed. We show that puzzle-based games may be more appropriate for this task, and we discuss some opportunities for algorithms, players, and experts to collaborate together and label large-scale accelerometer data sets that can be used in a lot of public health studies. The work was funded by National Institute of Health, and we are sincerely thankful to all the players on Amazon Mechanical Turk who spent their time playing the game and contributed valuable data for our pilot study. Thank you.
I was fascinated. What are your questions? Yes. And then in the back.
Hi, thank you for the talk. Sarah Wiseman, Goldsmiths, University of London. I had a question. Did you ever ask any of the Mechanical Turk players whether they considered this a game?
That's a good question, yeah. So
it looks a lot like a task, so I'd just like to know.
Yeah, no, that's one of the challenges we also had. So when they play the game, they have an option to provide feedback. So some of them did provide, some of them didn't find it like a game, but also, and the reasons they stated they wanted to play was because they thought it's contributing to science, but we don't have a lot of data to back that up. So only few players actually provided that feedback.
Hi, Vera van der Beek, KU Leuven. Yeah, actually, I think my question is resonating the same underlying thought that, of course, you want to trigger intrinsic motivation, or to a certain extent, you want to ensure that these participants actually enjoy doing this and would want to keep on doing this. But I understand that you currently don't have a measure for that, or? So
our primary purpose was to check if we can even gamify this task.
Yeah, sure.
So if we can get the quality labels that we can use in our research.
Yeah, future work.
Absolutely.
Thank you for the interesting talk. Katja Hoffman, Microsoft Research, England. My question is in the same direction as the previous two questions. I was curious if you provided any additional incentives that would gamify this. So for example, was there some kind of score or some match or something else that the player could obtain when they did the task correctly?
So in Mobots, if I can just quickly go back to the slide. So in case of Mobots, the player's goal was to completely fill up this power bar. And once they fill up the power bar, they move to the next level. And their goal is to reach as many or clear as many levels as possible. In case of Signal Liner, they had like 5 tutorial levels with the ground truth. And then they have one challenge level with unknown and ground truth data mixed in. And their goal is to completely solve the puzzle in that level. And so that's the game element in both the games.
That was like some very efficient question asking. We have time for more questions. That's so great. Yeah. Over there. Wait for the microphone, please.
Active, sedentary, or are you actually trying to obtain other labels?
Can you repeat through the microphone, please?
Are you just looking for active or sedentary, or are you trying to obtain other labeling?
So ideally we are interested in very specific labels, like for example, brisk walking, which is a more specific version of walking. So we are interested in labels like walking, running, sedentary, sleep, including sensor non-wear, which is basically a device kept on the table and still collecting data. So there are a wide range of labels that we are ideally interested in. The pilot study was done only with these high-level categories.
I'm sorry. Thank you for your question. I'm just insisting on the microphone because I've been sitting in the back during the first session, and I could not hear it. You might think you project, but you only project to the front.